Hello, my name is Masaki Hayashi. I'm from Department of Game Design, Uppsala University in Sweden. Today, I'd like to present my paper entitled Inducing Unpredictable Behavior in a Walking Fly by Destroying Neurons in its Neural Network through this video presentation. Here's an objective of my research: exploring the mysteries of life, especially regarding intelligence, instinct, sympathy, etc., through my method neurodrug that I named it, which is to deliberately destroy neurons in a neural network. Today, I'd like to explain my small project, which is a walking fly project. First of all, let's assume a walking fly, like this. If there are some stimuli around the fly, such as food, enemy, smell, sound, light, whatever, then the fly reacts to those stimuli to make an action. So which is called reaction. So it's not very difficult. However, if there's nothing around the fly, and then what is it going to do? So that's the question. So here's the question. If there's no external reason to stimulate the fly, when will the walking fly stop? After moving 1 centimeter, or 2 centimeters, or 10 centimeters, or until it hits the wall? So it's a very difficult question to answer. I think you agree with that, because you cannot predict it, and we don't know, and even the fly doesn't know. However, if you want to simulate the walking fly, it's not very difficult. It's easy to generate the fly's movement artificially by using computer program. These are examples. You can move it randomly by using random value generator, or you can assume a probability distribution of the walking distance. Then you can use a random value to control it. Or finally, you can assume an internal energy in the fly to control the walking by setting up a threshold with a random value. So there are many methods, from simple to complex. So it's very easy. But in any case, we need a random value, right? And the next question is, where does this randomness come from? Is the fly equipped with the random value generator? I don't think so. So here's my assumption. The fly has a tiny brain, so that tiny brain of the fly is controlling the walking. And possibly any kind of fluctuations is existing in the neurons in the tiny brain. And random process may be evoked through complex chemical reactions in the neurons. Even a tiny brain of the fly has so many neurons inside. Those neurons are always working by using this complex chemical reactions. And that may produce the random process. So that's my assumption. And based on this assumption, I figured out a project is a walking fly project. So I will show you this. And here's the walking fly project application. And it uses recurrent neural network to simulate the fly movement. And here's the configuration of the neural network. It has one input and 5 outputs. And one input is a walk or stop, it's a status. And then output is to make it walk and make it stop, make it turn left, make it go straight, make it turn right. Those are outputs. And it has one hidden layer, consists of 20 nodes, 20 neurons. And here's the recurrent path from here to there, because this is the recurrent neural network in order to adapt to the temporal behavior of walking fly. And first of all, this neural network is trained by using learning data. The learning data is quite simple. To walk 10 steps, then it stops 3 steps, and then start walking again 10 steps, and stop 3 steps. This is the learning data. And once the neural network finished to be trained, then the sigmoid functions in the hidden layer are intentionally manipulated while the automatic neural network simulator is running. So this is the method called neurodrug. Okay, so this is the simulation screen of the walking fly made on the Unity game engine. And here's the tiny fly is walking randomly. So please focus on this tiny fly. And here's the neural network. And there is one hidden layer here. This contains 20 nodes, 20 neurons. Output 5. And input is just only 1, but it's a recurrent neural network. So feedback data is added to the input, and this green one shows the input. And this shows firing or non-firing of all the neurons. And there is the 3 sliders here, and this first slider controls the amount of destruction of neurons. And the second one is the position of the destruction. I mean, these 20 neurons here, right? And where the destruction happens on these 20 neurons. This is decided by this position slider. And the final slider here is that this is the area of the affection. So control those 3 sliders, you can control the fly's movement, right? And actually, it's not controlling at all, because this slider is moved by manually. But however, I myself do it, but I cannot predict how the fly is behaving. So it's completely unpredictable. This is the point of the project. What I wanted to do is to generate unpredictable random movements without using random value generator. So that's my intention. However, as you can see, the current version of this simulator employs manual destruction of the neurons, because I myself control and change the three sliders to make the random behavior of the fly. So I myself am involved in the process. So next plan I will do is this. I will connect the destruction, which is 3 sliders, to the sensing data of the environment, such as temperature, moisture, sound, and lights, and whatever, to eliminate the human involvement. So that's the next plan, near future. But however, more importantly, I'd like to talk a little bit about the philosophical thought on this. In my opinion, there are two types of movements of organisms, left one and right one. And left one indicates the movement to react to external stimuli, which could be physical stimuli or objectives and motivations and whatever. And here's an organism, and it receives the stimuli and make some action according to the stimuli. And then it gives a reaction. And I think this is a mechanical reaction if the organism is quite simple, like walking fly. But in the human being, this process is so complex, so it turns out to be a reason in the human being. And finally, it turns out to be intelligence in the human being, because human being is so complex. But originally and initially, this intelligence, I think it comes from mechanical reaction, like this. On the other hand, another thing is a movement in the absence of any stimulus. And here's an organism, but it doesn't receive anything, any stimuli from the environment. Instead, environment itself is affecting the organism all the time. That means organism and environment form the world, the entire world. And the entire world and organism are communicating each other in unconsciousness domain. It may turn out to be some kind of sympathy. These two domains are making very interesting contrast to me. Well, so I don't have much time, and also this topic does not fit to this conference topic, so I stopped doing this and move to the final words from me. Apparently, this is not meant to be useful. Actually, it's useless. But however, my intention is to have a philosophical perspective in the AI and neural network discussion. And this is my opinion. Do not too much focus on consciousness and reason. Because recently, the AI technology is advancing quite rapidly and dramatically. So everybody is talking about consciousness and reason. But stop doing this for a while. And I would say we need to more deal with unconscious. Because the key might be there. So I would say, and this is my final word. All right, so this is the end of my presentation. Thank you for your attention. Unfortunately, I cannot attend the conference because of my health issue. If you have any question about my presentation, please email me. And the email address is on my paper. Thanks again. Bye-bye.